just published a new essay, Theory 2.0, and we want to discuss this essay here in this episode. The idea of Theory 2.0 is that we're going from scientists developing theories towards scientists designing AI systems that then develop theories. There is a 2.0 for scientists, there's a 2.0 for engineers, there's a 2.0 for artists. It applies to the same thing. I'm borrowing this concept from Andrej Karpathy's Software 2.0. And the idea is that the artist is not actually creating the art. The artist is designing an AI system that will then create the art. The engineer is not solving a technical problem. The engineer is designing an AI system that will come up with a technical solution. This is the gist of the essay. I'm going a little bit far out here. I'm starting with the concept that humanity sees itself through science. So whenever there are scientific breakthroughs, the zeitgeist changes. I'm going back to the 19th century, even further back, but I'm going to discuss this concept also in the words of The Painted Word, an essay by Tom Wolfe, which is, in my opinion, really one of the most interesting essays I've read in a long time. The idea is that we see art through what we think. And this concept of theory was born in the early 20th century in conjunction with developments in science, where we had people like Heisenberg putting a hard stop on observation. In other words, saying, look, there is a minimal amount of observation you can do. Everything else makes no sense. And if there's a hard stop on observation, then realism has to yield to something else. And that was conceptual art. In other words, thinking and then seeing through what we think. Today we are in a different world. We have new breakthroughs in science, in particular AI. I'm borrowing also from Jonathan Hurst, who gave a presentation at CMU, which I thought was really interesting. He was mainly promoting his company, Agility Robotics, but that's not the point. I think what's really interesting about Hurst is his idea of a new paradigm for engineering, which is very similar to my Theory 2.0, and that is that the engineer of the past was creating solutions to technical problems, and the engineer of the future will design an AI pipeline that will solve problems. Ultimately, the ultimate frontier of AI is to develop an I borrow Douglas Hofstadter here, and the development of an I is a really fundamental concept of humanity and consciousness. And just to explain what that means, imagine a robot that is ready to die for an idea, or a robot that refuses to engage with you because it doesn't like your idea. So to have that kind of deep feeling of identity, which is really what humans are all about, that would be the ultimate goal, which is partly what the Robinson Crusoe robot is trying to achieve, but that's only the beginning. This is Not Even Wrong podcast. It's May 6, 2024. This is Krim Delco. For the day, the fund is up 2.1%. The market's up 75 basis points. For the year, we are down 12.9%. The market's up 8.3%. We're underperforming by 21.2%. Theory 2.0 is a new essay we just published on Substack. The links are in the show notes. Let me start with the idea that inspired this essay. I think that humanity sees itself through the developments of science. What do I mean by that? I mean that we have breakthroughs in science, which is the closest we have to trying to understand the truth and what nature is all about. Now, we already have to assume, let's say people like Kurt Gödel have given us, or even Goethe in Faust, or in the Sorcerer's Apprentice, I think they've given us some hints that probably we will never get to the truth of things, because we humans have a certain way to perceive things, and that might not necessarily be the right way to look at the truth or what's really behind nature. But that doesn't really matter. Like Gödel said, in a sense, you can have a system which in itself is true but cannot be proven, and therefore is not really true, but it's true enough for us. And that opens the door for neural nets, which is really the prevalent technology of the 21st century. Let me go back to give a little bit of perspective. What I mean with humanity sees itself through the lens of science is, for example, we had in the 19th century the development of the theory of the gases through Boltzmann. And the idea there was, look, we can't really understand what every molecule is doing, but on average, we have a good sense for what they're doing. And this is sort of a little bit further step away from realism, which is, okay, we see exactly what's going on. And lo and behold, the Impressionists come along and say, we can design or paint the real world in a point cloud way. And by the way, that's still how we see the world today in AI. We look at point clouds because we're not really sure what the contours are. What is the contour of an object? Where does it start? Where does it end? If we go deep enough, we will find the Heisenberg uncertainty principle, which will give us a hard stop on where things end, because at some point, measuring will not make any more sense. But that's not the problem we have in the classical world. And in the classical world, we can just say, maybe things are just based on probabilities. Maybe things are just based on some sort of mixture of point clouds. And that's the 19th century. Then enter the 20th century. What happens there? We have the quantum physics revolution. And I think there's two fundamental things that quantum physics gives us. One is a hard stop on observation. And second, it also tells us that we can't deterministically say what's going to happen in our universe. Whether there is a multiverse theory and things like that, that is even a much further discussion. But we can't really be sure of what's going to happen at the micro level, and by the way, also at the macro level. So then, what can we do? And a solution is the idea of modernism. And modernism starts with Picasso, and I discuss The Painted World and also Les Demoiselles d'Avignon, a fantastic book about the beginning of modernism in Paris. And I think what's really striking about the book is how gradually this revolution happened. And the main revolution is really that what we see in a painting is what we think. We think first and then we see. And this goes back to that observations theory laden by people like David Deutsch even, or Popper. Like we decide what we see by what we know. This is the 20th century. And it's a nice example of how the world really is driven by the zeitgeist, and the zeitgeist is driven by science. Enter the 21st century and the breakthrough of AI. The breakthrough starts with ImageNet and now with general pre-trained transformer. We will have a lot more breakthroughs. I think the two most interesting parts of AI today, in my opinion, are simulation and reinforcement learning. I'm going to discuss this a little bit deeper, but what it culminates into is that in the old world, the scientist develops a theory. In the new world, the scientist designs an AI system, which then develops a theory. And this starts with observation, but then the observation is fed into a simulator, and the simulator, based on the observation, creates a Monte Carlo distribution of possible representations of the world. So if I have an egg and the egg is falling, that egg can fall in a billion different ways on a billion different surfaces, and all kinds of things can happen. Some of them might be completely Harry Potter type worlds. Some of them might actually be more interesting. Let's say it just falls on concrete or it falls on sand. But the key here is that we have the ability to iterate at scale in parallel. So we can, to paraphrase Jonathan Hurst, that is an entrepreneur that I'm borrowing from also in this particular episode. He has a presentation, it's in the show notes, where he presents Agility Robotics. He talks about engineering, and he talks about engineering 2.0 the same way that I'm talking about science 2.0. The old engineer is creating solutions to technical problems. The new engineer is designing an AI system to create a solution. So Jonathan is mentioning the parallelism that simulation allows. So imagine you can, in parallel, catch eggs. You can have a billion eggs falling in a billion different ways, and you can then, through the design of clever algorithms, figure out the scenarios where catching that egg actually works and the scenarios where it doesn't. And then you can go from there and design an AI system that successfully catches an egg. And then you can infer from that what it actually means to catch an egg. You can even infer laws of physics. In fact, you can probably infer new laws of physics that we don't even know about today. And the key to innovations are, according to Jonathan, are simulation and reinforcement learning. So that's the key to the future. Both of these we've discussed at length in this podcast series, but I just want to focus on them just real quick. So what does simulation mean? Simulation means we have to build a representation of reality. In particular, we have to solve the inverse graphics problem. We have to be able to represent real 3D objects in virtual world by implicitly also representing the physics. This is going to be important. So if we have an egg falling, we want to make sure that we can implicitly represent the physics. And we can do that end to end. So we don't have to explicitly actually define what an egg is, what the inertia are, the forces and the weights. We can infer that from vision, or at least that's the goal. According to Jinjendra Malik on a recent presentation, this is not that far away. Think of it like also computer vision 2.0, right? The vision number one was classifying. Actually, even detection and classification. Detection was already hard. Okay, how can I detect a pedestrian? How can I distinguish a tree from a pedestrian? Things like that. I think we're on the cusp of solving that with segment anything and things like that. But what we don't have right now is a good representation of objects with their physics. So we need to work on that. And once we have that, reinforcement learning is an optimization solution to the trajectory problem. So if I have a bunch of possibilities, in fact, what is possible, it's represented to me in virtual world. So I have the access to what's possible. And now all I need is some sort of algorithm that helps me get through that maze. And reinforcement learning could be the key. In other words, reinforcement learning is developing a cost function that has rewards and punishments in it that help the agent navigate through the maze. This is roughly the idea of Theory 2.0. Again, we have this representation of the real world that comes from the scientific breakthroughs that we had, and it's going to change science. So this is what's new about this is that this time around it's different because we're not changing the zeitgeist through innovations in science. We're changing science through innovations in science. So there's a loop here. So the changes in science, which are driven by the evolution of AI, in particular the ability to represent the world in a semantic way through large language models, thanks to the internet and the training and the transformers, and this new ability to have also robots or AI systems move in the real world. It's a breakthrough in science which will change science. So this, in my opinion, is the biggest takeaway from this essay. And finally, I want to talk about the ultimate frontier of AI. The ultimate frontier of AI is actually an AI system that develops an eye in a Douglas Hofstadter type way. And just imagine a robot going to die for an idea, or refusing to engage with people because it doesn't agree with their idea. So to me, that's the ultimate frontier of intelligence. It's this ability to do something that the identity of the person, of the thing actually represents. We're not there yet, and we have to at least make a few steps in between. One of them would be the Robinson Crusoe robot, but that's sort of just as a icing on the cake, if you will, to get a sense for where this is going. So to summarize, Theory 2.0 is the idea, it's an essay that we just published, but the idea that we have breakthroughs in science typically define the zeitgeist of humanity. This time it's different because the breakthroughs in science are not just redefining the zeitgeist, but changing the way science is done. In particular, the new type of science is the scientist is designing an AI system that interacts with the world or in simulation and the world and creates solutions to problems, develops theories to problems, develops technologies to solve problems. So that's the fundamental difference. Think of it also this way: we're replacing engineering hours or scientist hours with GPU hours. Thank you.